Any questions about the previous sessions? We covered word representation. Okay, in that case, we can start with the first application of natural language processing. And then we're going to start with text classification because that is a topic that we can understand the most. And you can think of it in terms of applications. There's going to be some emails coming to your inbox, and then you want to make sure in an automatic fashion that you're filtering out most of the spam emails. And the way that you're going to be doing it is using a text classifier. Given the content of that email, which is a text, is it a spam or is it not a spam? And let's say you're a company that is one of your services is giving people email accounts. For instance, your Google or your Microsoft or your Yahoo. To make your customers happier and delight them and convince them to use your service, it's going to impress them the most if they're seeing the least amount of spam showing in their inbox. So you're able to filter them out. So behind the scene, there is going to be a machine learning algorithm filtering out emails. Okay, these are spam. These are likely to be not spam. And you can let them end up in your inbox or in your customer's inbox. And that way you're increasing the profit for your company. Another application is sentiment analysis. Most of you went online. Maybe you're booking a hotel, maybe you're booking a flight, maybe you are going on Airbnb, maybe you're going on Expedia to book a hotel, maybe you're buying a simple product on Amazon. And most of the times, if you are happy, you're going to write good review about that product or about that particular restaurant that you went to on Yelp. You write a review. Now let's go ahead and look at it from the perspective of the company. There is going to be reviews on your website about your products. It's going to be a lot of reviews and you're offering a lot of products. So it's all about the scale. So it's a large scale effort. It's a big data effort. So it's not going to be possible for your employee, maybe you're hiring somebody, to look at every single review on your products and then try to get a sense of the feelings of the customers about a particular product. Maybe you want to take it down from your website. Maybe people are not happy with that product. So these sorts of large scale applications where a human can do it, but then it's going to be really costly for a human to be doing that. It's a lot of data to go through. In principle, a human can deal with small size data, but when the data becomes scalable and large, then it's not feasible anymore. And that's where your machine learning application is going to shine. You're going to put the text classifier. It's going to classify the text as it's a positive review, it's a negative review, it's this much positive, it's this much negative. And then based on those reviews, you can decide to keep a product on your website or not. And this way, make your future customers happy. And there are a lot of other applications to text classification. Let's start with recursive deep models. Here, I'm not particularly interested in the model. I'm interested in introducing you a data set, which is basically a sentiment Treebank, and how you can actually do data exploration. So this paper is mostly about introducing the paper rather than introducing a new model. But we are actually going to go through the model because it's actually a good exercise for us. The video is online, so it's one of your assignments to watch that video. The data set is going to be Stanford Sentiment Treebank. The data set is already labeled like this, so a tree already exists for the data. But our end application doesn't need the tree, and we are going to later on come up with models that are not based on a tree or any labeling of this sort. All you need is the input sentence and the output label. Was it a positive review or was it a negative review? But the data set is like this. Every single word is labeled as positive or negative. Every pair of words is labeled as positive or negative. For instance, doesn't is negative. And then you can keep merging your words. So there is already a parser, which is going to take these many sentences and it's going to give you this many trees. That's your data. So what I'm showing you here is an example in your data. And you can immediately notice that this data is not tabular anymore. What do I mean? You cannot take this observation and put it in a row. of an Excel spreadsheet, because then you're going to put a next row and then it's going to have a different structure. So you're going beyond tabular data. What else? This data set has very negative, negative, neutral, positive, and very positive as its labels. There is another version of this data also where you have positive and negative, only 2 classes. This one is more fine-grained. You have 5 classes. And then you can look at, this is data exploration. You can look at all of the unigrams in your data, which are these single words. And then you can see that most of them are neutral, and it makes sense. If you have a single word, it's really hard to associate to it a sentiment. But as you combine more and more words together, then your distribution is going to become more diverse in terms of the classes. So this is a data set. What I want you to do, and this could actually be one of your assignments, to go ahead, download the data, and explore the data. Do exploratory data analysis, because the data is a source code for deep learning. And why am I saying that? You look at this tree structure, and immediately you're going to think that I'm going to write a deep neural network that is going to respect this tree structure. And based on that, you're going to end up with recursive deep neural networks. So this was an assignment for you to watch this video about the model. Are there any questions? So we are introducing 3 different types of models: recursive neural network, matrix vector, recursive neural network, and recursive neural tensor network. Any questions? So one objective I have from going through this paper was to introduce the sentiment Treebank data. That's the priority, number 1 priority. The second one is to introduce recursive neural networks and to say that recursive neural networks are not recurrent neural networks. They're different. They're based on a tree structure.
I have a question. Can you hear me?
Yes.
Oh, good. I have a question about the inference time for this model. So when parsing the n-grams of a new vocabulary that's not seen in the training data, would it depend on if the combination, I mean, if the n-gram is not present in the training data, would that still work?
So I think your question is actually more fundamental. You're asking if I want to have an open vocabulary. Maybe I don't want to work with unknown words. So one solution to what you have, what you're saying, and it's a naive solution, is if you encounter any new words that you haven't seen before, you're just going to put them in the bucket of unknown. So basically the size of your word embedding matrix, you're increasing it by 1, and that 1 corresponds to the unknown word.
So those words will not be used for drawing the conclusion?
No,
okay.
And that's exactly one of the drawbacks. But then later on, one other solution that we saw for dealing with new words when it comes to testing was working at the character level, or actually at the n grams at the character level, when your grams are actually characters. And this we saw it before. There is also a downside to it. You're increasing the size of your vocabulary by orders of magnitude. So later on, we are going to actually deal with the open vocabulary problem in a very beautiful way. So I'm going to go through that paper and you're going to love it.
So if the word is present in the original corpus, but the combination is like a different order, if it is not in the original tree bank, would that still work?
Yes. So now your question is about, I have a new sentence. So first I answered your question about I have a new word. What if you have a new sentence? And that's actually your testing. The first thing that you're going to do is you're going to take that sentence, push it through the Stanford parser. It's going to build a tree out of it. And once it builds a tree, then you can take that and feed it through your recursive neural network. So that's actually one of the downsides of using recursive neural networks is you need to build your tree first. So it depends on some parser. And later on, we're going to write down different models to actually take care of that problem, to get rid of this parser. And one of the promises of deep learning is being able to work with raw data. So we want to be able to work with raw sentences. So does that answer your question?
Yes, thank you.
Okay, perfect. So this was a good discussion. Now you know what you need to do. What are the requirements for this model to work? Any other questions? So when you are watching these videos, you don't have the chance to ask me. These are the questions of your peers from last year. But this semester, we are covering more papers, and therefore you're going to end up with more questions. So don't be shy. Ask as many questions as you want.
So this parser works very integrated with our model, correct? So you're saying that we cannot really do much if we do it with a recursive neural network without this parser for each sentence we want to do.
Exactly.
Okay.
So this model depends on the parser.
And it seems like it depends quite a bit if this parser is generating a sentiment for each sentence, correct?
No, the parser is not going to generate the sentiment. The sentiment, you're going to let your neural network do it. All you need is merging these words together.
But we have the tags for each word of what sentiment they have, correct? So like each individual, no, even that's not, okay.
So when it comes to testing, all of these minuses, zeros, they're all gone. All you have is just a tree.
Okay.
And then your neural network is actually doing the labeling for you.
I see. Okay.
Actually, to collect the Stanford sentiment Treebank, they had some sentences. They would push it through the parser, and then they would give those trees to a human labeler. And the human labeler would say, cleverness is positive. We'll put a positive here. We'll put a positive on the pair of cleverness and comma. So all of these are done by a human, the labeling part. Any other questions? Did I answer your question?
Yes.
Okay, perfect. Okay, this is your last chance. Any questions from this?